Alright, join me for the math on the spot video. If you don't have scratch paper, get some now so you can follow along. Okay, here we go.
Oh, hi, how are you? I'm just listening. Wait, hold on a second. Sorry about that. I was listening to some really great math stuff. Kind of fun. Actually, listening to these songs, reminds me of a great riddle, in fact, about students and how many songs they actually purchase as MP3s. Let's take a look at ourselves and see, in fact, how we can use statistics to even understand music better. Let's check it out. So, Jason collected the data about the number of songs his classmates bought online over the past 3 weeks, and he made this dot plot. Now, Trinity surveyed her classmates about how many siblings they have. Now, a dot plot of her data increases from 0 siblings to a peak at 1 sibling, and then decreases steadily as the graph goes to 6 siblings. Now here's the question for us. How is Trinity's dot plot similar to Jason's, and how is it different? Now, what's interesting about this is, here we can see Jason's dot plot, but we're not even given Trinity's dot plot, and yet just the information we're given in words will allow us to say some things about each and compare and contrast them. So first of all, let's just take a look at Jason's. So, and this again is really take a look, because we can look at it. So Jason's dot plot. Well, what's the first thing we see? The first thing we see is it has no clusters. No clusters, meaning that there's not, they're not all kind of clustered together next to, kind of all 1 or 2 values. They're just spread out. There's a spread here. So there's no clustering. That's good. Now, notice that it actually basically has a little gap here at 2, meaning that there were actually no students at all that purchased exactly 2 songs online. They purchased 1, and they purchased more than 1, but not 2. So we call this a gap. So there's actually a gap at 2 songs. Now, whenever you look at data, you always want to know the most popular data point. That would be where the peak happens. And here we see the peak happens at 7, and we can see that because that's the highest point. Now, by the way, let me just say a little word about when you're making these dot plots. Because if you're making dot plots on your own, you want to make sure that the spacing between the dots is the same. It's uniform. Because you could imagine drawing 7 dots, 1, 2, 3, 4, 5, 6, 7, and it would visually look like it's actually low. You see? So it's really important when you create your own dot plots. This is a professionally drawn dot plot, because I'm a professional. But when you draw yours, I want you to draw them like professionals, which means that you have to make sure that the spacing between the dots is uniform so that you can really see visually where the highest point is. You can draw 7 dots really tightly, and it wouldn't look visually correct. So here we have it visually drawn correct, and so we see that that's the peak there. And notice, by the way, visually, it looks like that around 7, there's kind of a mirror image of itself, right? These points drop here, and the points drop here kind of similarly, and we call that a certain amount of symmetry. So we can say that the dot plot is symmetric around 7 songs, that what happens before kind of looks like the mirror image of what happens after. That's just some observations about the data, looking at it visually. Now, with Trinity, all we have are the kind of the information we're given. We don't actually have the visualization. So what can we say about Trinity's? Well, Trinity's actually, what do we know? Well, first of all, we know it's a dot plot that increases from 0 siblings to a peak of 1 sibling. So with Trinity's, and again, we don't even have a picture of it, but we can just think about it. We know that it starts at 0 siblings. We know that it has a peak at 1. And then we're also told that, in fact, after 1, it decreases steadily until we get to 6 siblings. So decreases steadily until we get to 6 siblings. Oh, I want to line these up nice. Now I want to make them look nice for you. Yeah, Professor Berger's making it look nice. Okay, great. So let's take a look at the similarities and the differences. So what are the similarities? Well, the similarities, I would say, both dot plots increase to 1 peak and then decrease again. In this case, the one peak is at 7 songs, and in this case, the one peak is at 1 sibling, and then decreases from there. So there's one similarity. And what about the differences? Well, there are actually a couple differences. One difference is that Jason's plot has a peak in the middle of the range. You see, going from kind of 1 to 13, 7 is kind of in the middle. Whereas here, with Trini's, she goes from 0 to 6, but the peak is at 1. It's way off to the left. It's actually at a lower value. And Trini's dot plot peaks at the lower end of the range, which is what I just said. So in fact, here you can see some differences between the two dot plots, and here you see a similarity. What's really fascinating is that whether we're visualizing the data visually as in a dot plot, or even descriptively using words, we actually can say something about the data. This is what statistics is all about. It's about looking at data and not looking at them as individual dots or as individual numbers or as individual facts, but rather as a totality. And as we look at them together, all told, we're able to actually see interesting things about the data. In this case, we can gather information about symmetry and where the peak is and clustering and so forth. Anyway, to me, when I look at data, the data sings to me. In fact, that reminds me, I really want to get back to my music because, in fact, when I think about singing, I think about music, and when I think about music, of course, I think about, I'm going to push play. Have fun with that. I'll see you soon.
All right, thanks for watching, and I'll see you on the next one.